Okay guys, here I'm going to be talking about piecewise functions, which will help you with the assignments and help you understand and get ready for any quizzes or tests that are coming up. Before we get started on looking at this piecewise function, and I want to just make sure that what you're going to see on a test, I have a lot of things here written just to save me some time, but what's inside the dotted box here is what you will see on a test or a quiz or a homework when dealing with piecewise functions. A reminder on graphing. The best way is to set it in y equals mx plus b, which is slope-intercept form, which is nice because piecewise functions will always, for now, will always be in y equals mx plus b or slope-intercept. So I don't have to do anything with these functions. They're set up nicely for me like this. Remember, m is your slope, or the number in front of the x is your slope, and the number that's alone with no x is my y-intercept. I wrote start here because when I start graphing these functions, I will always start with my y-intercept, which means my first point will be here on this y-axis. That's why it's called y-intercept. Again, my first point should always start here on my y-axis. So let's start graphing. And I've color-coded these. So the first function, all I've done is taken these functions and written them out again, these two. And I'm gonna start with the top one, which is f of x equals x plus 4. And I color-coded it red so that you can visualize and know which line goes to which function. So I'm gonna start with the red one. My y-intercept here would be a positive 4. Choose or start with a number that does not have an x. So 4 is alone. So that's a positive 4. And we said that our first point will always be on the y-axis. So if it's a positive 4 and this is 0, my negatives will be down here, negative 1, negative 2, negative 3. But we want a positive 4. So I'm going to move 1, 2, 3, 4. And my first point is plotted. Then I go to my slope. Now, if you have a slope here, you don't see a number there, but there's a 1 there. Okay, so my slope is 1. I need two numbers. I need to make it a fraction. If it's a whole number like this, we just put it over 1. Okay. For this function, it's already a fraction, so I can rise and run, or move vertically and then horizontally. Okay, so my slope is 1 over 1, which is an easy one. It's a positive 1, so I'm going to move up 1, and then it's a positive 1 denominator, so I'm going to move to the right 1. Up 1, right 1. And I like slopes of 1 or negative 1 because they hit all the corners. They hit every corner. Okay, I'm just going to continue here. Now, if it was negative, I would hit the corners, but it would be going down. Remember that if my slope is positive, my line should be going up from left to right. And if I take a look at these two functions, both slopes are positive. So that means that both of my lines will be going up. Okay, and I'm going to leave it like this for now. You know, I have enough dots plotted there, and I can kind of get a vision of how my line's going to look like. Once I graphed the first function, let's move to the second function. I'm going to use green. Again, we start with y-intercept, the number without the x. 1, it's a positive 1. And my first point will always be on my y-axis. This is 0, this would be negative numbers. If I want a positive 1, I would just have to move up 1. And I plotted my first point. Then we take a look at the slope. My slope is 1 over 3. It's positive, so remember my slope is going to go in the upward trajectory. So I'm going to rise 1, run 3, or move up 1 to the right 3. Up 1 to the right 3. 1, 2, 3. And that's where my point will be. I'm going to move up 1 to the right 3. 1, 2, 3. Up 1, 1, 2, 3. And you see this trajectory? You can also do down 1 to the left, 3. Down 1 to the left, 3. 1, 2, 3. 1, 2, 3. Okay. There, I've plotted these both, practically almost graphed both functions. Once I have it here, now I have to go to my if statements and see what I'm gonna keep. Okay, so the red function is the top one. And I see a 1 here. So that's where I'm gonna go. I'm gonna go to where x is 1. Where is I labeled my axis, here's x, here's 0. This would be 1, a positive 1. So I'm gonna just put a dotted line through here. Just to represent that this dotted line is where x equals 1. And I notice that this point lands on 1. And it says, if, or let's read it this way. These are the values that I'm going to keep. So x values that are less than or equal to 1, I'm going to keep. Less than 1, well, what's less? Well, 0 is less, negative 1 is less. Okay, so I'm going to keep those values, anything that's less than 1. Well, here for my red function, anything that's less than 1 would be on this side because I have all my negative numbers here, less than 1. So I want to keep those. Anything to the right, I want to erase. I'm going to erase. Notice that my inequality sign here has a line underneath. And that's why I wrote this. And this is something you have to remember. Because it says x is less than or equal to. So it actually lands on 1. And that's why we symbolize it with a closed dot, filled in, which it already is. So now all we have to do is connect the points. And we're done with the top function. Moving on to the green one. Again, x is greater than 1. So I want to keep everything on the green line where my x values are greater than 1. Okay, here's x equals 1. So anything that's greater than 1. Well, what's greater than 1 would be like 2, 3. Anything to the right would be greater because I have my negatives down here. That would be less. And I don't want less. I want all the values that are greater than 1. And that's why I keep these values. Now, I don't have a point here. My point was actually here. Okay? And I have no point that lands like this one, that lands on 1. But you can see the trajectory here. You can see how it goes. So you could just somewhere around there do an open dot and connect the points. You can get rid of this guide here, and that's it. Both functions are graphed with their if statements.